right? We know that it's best to use the N and T transformation, right? Transformation means what? This is your T, and this is your what? Your N. That's the best approach. The second thing that you learn is followed by this. You do your summation of forces in the N and P component. Do not forget, whenever you have something like this, you know that the acceleration in the tangential direction is equal to alpha r, and the acceleration in the normal direction is equal to omega squared what? R. Okay, I realize in term test 2, some of you forget the normal direction. You just focus on the what? Tangential. That's where it's unfortunate you do lose marks on that. The next thing that you learn, do not worry about where the moment is taken what? From. I just show you that. Yes or no? Right? You take from any points, the results will be and shall be the what? Shall be the same. Okay. So knowing that AN is equal to omega squared R, okay, comma, to obtain omega squared relationship, right? We need to apply alpha d theta is equal to omega d omega. Yes or no? That's the last step we have done, right? Then the next thing that we know, when no slip condition, okay, can use A is equal to alpha R, and do not use FR or FF is equal to mu N, right? And then when there's a slip condition, analyze with FF is equal to mu N, and do not consider alpha is equal to what? Alpha is equal, or A is equal to alpha. Or do not use, not consider. Okay, so these are the rules that will be applicable in not just this case. A lot of cases are very similar. Are we clear? Yes. I've not done general motion yet. Okay, these are just fixed motion. Rotation about a fixed axis. For now, okay, so maybe tomorrow, general motion. Yeah, that's general motion. But down here, we are only acting at the boundary. We have not considered full direction yet. This is just about to happen. Okay, right. The next problem that we're going to do is very abstract. It's about this boy that's rolling over. Okay. So this problem that you see is what I like to call, okay, a multi-body problem. What do I mean by multi-body? Is you have the wheel and you have the boy. Okay. What are you more interested in? The wheel or the boy? Right? What are you more interested? Are you interested about the wheel or are you interested about the boy? Okay. Right? Oh God, that giga is contagious, man. Right? Come on, share that joke, you cheeky sod. It's so bad that. Right. Let's read. A super lightweight boy, which has a body of 40 kilogram, sits on top of a large wheel and has a mass of 400 kilogram and a radius of gyration. Okay, if the boy essentially starts from rest, is it the boy? Oh yeah, at theta is equal to 0, and the wheel begins to rotate, determine the boy, yeah, right. Determine the angle which the boy begins to slip, which the boy. The emphasis over here is, this is not very right. The human, okay, begins to what? To slip. The coefficient of static friction between the wheel and the boy is 0.5. Neglect the size of the boy. This is garbage, you know. It's telling us it's freaking 40 kilogram and said, neglect the size of the boy. Okay. Neglect the size of the. So could you imagine all of you are doing this and down here is water and then go down. This is Niagara Falls. Can you imagine that, right? That's where the excitement comes, yes or no? Right? You're going to, right, dude, okay. Right? You get what I mean? Okay, so this is so-called the fun question. So now the bit that is, by the way, the math is real straightforward. Okay. So now the abstract is when to concentrate on the wheel and the boy, and when just focus on the where? On the boy. Okay. So looking at the summary that we have done, what coordinate system will you use? NNT, yes or no? Why you decide to use NNT? Because it's rotating about what? Agree? Okay, so we start from there. Same thing like before, right? We analyze the free body diagram, okay? But when does friction actually happen? When the boy actually starts to what? Sleep. We clear. Okay, so we have so a big hint over here is the boy starts from rest at theta is equal to 0. Okay? No. I'm just simulating. Why? Now, listen. If you ask me, I do this question by looking at how things are, I can't do it. And again, this question is probably very abstract. I have to refer to the solution method. I'll tell you this, I'm honest with this. Okay? I have to what? Refer to what? Okay. However, the difference between a gorilla like me looking at a reference, solution table, and you is this. I could explain why every step is what? Taken. Because I did not need to support that. Okay. What I'm going to do now, I'm going to explain to you why every step has been taken. Hopefully, it will enhance your life. Okay. Really, I looked at this question 2 weeks ago. I sat down, not a clue, man. I will tell you that. Why not a clue is it the wheel or the what? Or the boy? I formed a ginormous equation like you. Okay, sit down for 3 hours to not get an answer. Okay, I will spend 3 hours because I don't have 7 crazy subjects for you guys. You guys have 7 subjects to study. I go. Are we clear? Right. So we go from here. Niagara Falls is very sensitive now. Let's not go there. So the first thing that we do is we know I'm going to call this point, okay? So now this radius of gyration over here, we're going to apply, okay? And this is equal to what? So this is the mass moment of inertia for the what? For the wheel only. And you are aware that we have a formula which is what? Mk squared. Yes or no? Right? So this will be equal to mass is equal to 400. The radius of gyration is 5.5 squared. So this will finally be equal to 400 times 5.5 squared is equal to 12,100 kilogram meter squared. Likewise, like before, we look at the free body diagram. So we're going to deal with forces. So by looking at the forces, okay, the first thing that we are going to do, we are going to assume, okay, we are going to assume that the boy, the boat, really, the boy is what? Not sleeping. So the boy's butt is glued. He is not sleeping. Okay. So what we have is the boy's center of gravity is here. So over here, this is the mass of the boy. 40 or the weight times by 9.81. And this will be equal to 392.4 Newton. We know if the boy were to sleep, it will be in this direction, and this will be your tangential direction, and over here, this will be your end direction. I do apologize, I should have drawn here. Okay, so we know that this is the T, and towards the center, this is the end. So from here, we break them down into 2 components now. We know this direction over here. Oi, stupid mouse. Right. Okay. So, sorry. I think if I draw this side, it's clearer for you. Okay. So we know over here, due to alternate angles, this is theta. So over here, this is our 392.4 sine theta. Then over here, this is our 392.4 cos theta. Okay. And we will come back to this problem tomorrow. I'll see you guys tonight at 7, and we will finish hopefully most circle tonight.